Hey guys, Obi here. So today we're going to talk about latent heat of evaporation. It is probably one of the most important things you need to understand to be able to understand how an AC system works and how to diagnose it. So to do this, I think it'll be pretty simple. Just have a couple things. First, we have a thermometer, either an analog or a digital one. Some ice, water, and then my favorite, a torch. Okay, so the first thing I want to do is I want to talk about ice itself, okay? So we're going to see what temperature water is when it actually is, when we pour water. Let me start that over. So the first thing we are going to do is we are going to actually see what temperature water gets to when we put it in ice. So the first thing we want to do is actually figure out what the temperature of ice is. Okay guys, so the first thing we're going to do is take our thermometer and we are going to check the temperature over the ice, okay? So we're going to try to stick this down at the bottom and get a good probe on one. We're going to watch this temperature, see at what point it settles at. Looks like we're just going to make it into 26.8, maybe 26.5 degrees if we wait long enough, but 26.8 is pretty close, 26.6. Okay, so we know we're about 26 degrees on our ice, okay? So the next thing we're going to do is add water and check the temperature of the freezing of the ice, okay? So let me pause this and let's get there. Okay, so now that we've done that, I want to put the water in and I want to see what the temperature is of the actual water when we put it in ice. So while we put this in, we're going to think about this a little bit and you guys can tell me what you think. So do you think the water is going to get to 26.5 degrees like the ice was? Or do you think it's going to be about 40 degrees or, I don't know, 30 degrees or 32 degrees? What do you think? So let's go ahead and take both of our thermometers. We'll just go ahead and check. We'll stick this one in here. And we'll flip it so you can see it. So right now our temperature shows about 40. And then this one we'll put in here. I do have to keep it away from the ice. That is kind of one issue I run into. If I don't do that, it throws it off. And we'll hold this one up about right here. So you see that the analog one is already down about 232 degrees pretty much immediately. The digital one is sitting up around 36 degrees. Let's wipe it off and see. There we go. So we're dropping down to around 32 degrees now. Watch this. So the first thing I want to tell you guys, water always is going to be at 32 degrees when you put it in ice. So ice will always melt at 32 degrees. So that is a transition barrier layer between a solid, that is ice, and a liquid, that is water. So we can see that both of these are at 32 degrees. Now the cool thing is, knowing that water is always going to be at 32 degrees if there is any ice in the water at all, it's probably a really cool way for us to be able to calibrate our thermometers, right? That's what I thought. So both of our thermometers look to be doing pretty doggone good. Pretty close to 32 degrees on both, kind of hard to see. Okay, so just another little neat thing for you guys. When you pour salt in your water, that actually makes the freezing point drop a little bit to around 30, 29 degrees. So if you were really interested in that, you might want to put a little bit of salt in your water, and that'll help keep whatever beverages you may have a little bit colder, okay? All right, so the next thing we're going to do is we're going to talk about what happens when we heat our water, okay? So we'll set this off to the side. Now we'll pause it here so I can get set up. Okay guys, so the next thing we're going to do is we're going to take our torch and we're going to heat this up until this starts boiling, okay? And we're going to let this fast forward until we get a little bit warmer, all right? Okay guys, so it looks like our temperature is actually starting to rise. If you guys can look in the back, you're starting to see some moisture. The water swirling a little bit. We can see a little bit of bubbles, but it's not doing too much yet. So we'll keep watching. Our temperature will rise a little bit more. Sorry we're having the trouble seeing this. As it turns out, this thing is getting a little bit of moisture on the inside. Probably something to do with the crack on my lens. So 200 degrees should be about right there. So we're getting close to the boiling point of water. So as we begin to approach that boiling point of water, we're beginning to see a little bit more swirling going on of the water. Let's see if we can check it with our digital thermometer too. So if you look now, you can begin to see some bubbling going on. So if we're watching this right now, it's kind of hard to see. Let's see if we can get this one to come up. So we can see there's actually a little bit of difference between our two gauges. The analog gauge is looking to be right at 210 degrees and maybe 211, and the Accurite is about 205, and that is a difference in gauges. So I'm going to go ahead and go off of the analog one because it's actually seemed to be more precise throughout this entire test. Okay. So what we're seeing now is that our water is boiling, and we have a pretty healthy boil going on right now. And what we're seeing is that our temperature is not going any higher. So why is that? So it should be that as our temperature increases, our water temperature would increase, right? Well, this is where latent heat of evaporation comes into play. It takes energy for that water to boil. And by boil, I mean it takes energy for that water to go through the phase transformation from a liquid to a gas. So guys, what I want to make sure you understand is we are putting heat energy into the water from the torch. Okay, so that flame is hitting the side of that aluminum can, and we are putting heat directly into the water, and that is causing that water to boil because water wants to turn from a liquid to a vapor at 212 degrees at sea level. One thing to note is that is affected by elevation, and actually if we are here in Greenville, Ohio, our boiling point is actually approximately 210 degrees because we are 1,000 feet above sea level. Fun little fact for everybody to know. So what actually happens is when the water boils, the heat energy that causes it to boil goes away with the steam. So the steam itself is actually cooling that water down. That is why the water cannot get above 212 degrees. Now, in all reality, if we were to put a ton of heat into this, we could get that water to go higher. It's really dissipating the heat out of it when it transforms from a liquid to a gas. Okay? So, alright guys, I hope that helps you understand what latent heat is and how we can store energy in our phase transformations from solid to liquid and liquid to gas and so forth. That'll be it for today. I will talk to you guys tomorrow. Bye.